Okay, so let us discuss the apparatus that are commonly used in analytical chemistry. And we have here different classifications of apparatus depending on the units no, or depending on the fields that they measure also. So we have here apparatus that are used to measure mass. We also have apparatus that is associated with weighing. We also have filtration and ignition of solids ng mga apparatus and apparatus that are used for measuring volume. Now let us start with the apparatus or equipment, laboratory equipment that are commonly used to measure mass. And first we have here the analytical balance or the electronic analytical balance. And the main job of this electronic balance is to measure the mass of a particular object, may it be liquid or solid, with high accuracy. It also uses electromagnetic force compensation to balance the load on the pan, and it has a maximum capacity that ranges from 1 gram to several kilograms and a precision at maximum capacity of at least 1 part in 10 raised to the power of 5. Now we have here different types of analytical balance depending on the amount that they can weigh. We have the macro balance, this one. We also have the semi-micro analytical balance, which is this one, and the micro analytical balance. Now, macro balance is a type or form of analytical balance that can weigh between 160 grams to 200 grams and a precision of 0.1 milligram. So, ang kaning 160 to 200 grams mo ni ang kayang timbangon ni macro balance. And so, any mass beyond that, dili na niya kaya. Then we also have the semi-micro analytical balance, and it can weigh masses of up to 10 grams to 30 grams, and it has a precision of 0.1 milligram. For microanalytical balance, from the name itself micro, it can weigh masses that are very small in a way, no? Ranging from 1 grams to 3 grams, and it has a precision of 0.001 milligram or 1 microgram. Now, analytical balance has different parts. It has glass door, draft shield, door handle, and a lot more. So as you can see here in this picture, the glass door, these are the glasses or the glass na makitaan on both the left and the right side of the electronic balance. Meanwhile, the door handle, this is the part of the analytical balance in which mo ni ang gina-open and close. Or pwede mo po ni siyang sa kilid, pwede mo po siya i-open and close. So the door handle, you can see here kanang murag iyahang gunitanan para mag-abri, yun siya. Then we also have the draft shield, then the balance pan. So kaning balance pan class, this is where we place our container, the solid, and the liquid nga itong itimbang. We also have here the display. As you can see here in the display button, dili na to makitaan pila ang timbang sa object nga atong gi-weigh. Then the power button, of course, this is where we turn on and off the electronic or analytical balance. We also have the function button, the tare button, which zeroes out the display button. So, ang main function ng tare button is that siya ang mo transform sa or siya ang mo make sure nga zero tanan ang nakabutang there sa display, which also signifies nga zero na siya. Like, wala siya timbang or wala siya mass. And then we also have here the level adjustment feet. So this is where we adjust the height, no, the elevation of our analytical balance. Now, electronic analytical balances class, they have an automatic tearing control that causes the display to read 0 with a container, such as a boat or weighing bottle on the pan. Now, some analytical balances, they have automatic tearing control in which inibutang nimo sa container, may it be katong mga sudlanan sa mga solid, baka nang atong butangan nato sa mga object ni pangtimbang nato. May ubang analytical balance nga automatic ma-zero na sila. However, for some, kailangan pa nato tuplokon or pinduton ang tearing control or katong tear nga button. And if mapindot na to siya, then automatic nga 0 na ang ma-display even if na ay container sa sulod dito sa balance pan. Now, a tear is the mass of an empty sample container. And tearing is the process of setting the balance or the analytical balance to read 0 in the presence of the container. Na maski na ay container sa sulod, if atong i-tear, automatic mo-0 siya. And so, where should we place our analytical balance? Pwede bang dala-dalaon na to sa classroom? Of course, as we can see here, an analytical balance should be located on a heavy table such as marble slab to minimize vibrations. Now, this is the reason why we are not allowed to borrow and bring the analytical balance from the central lab to our classroom. It's because to minimize the inconsistencies. So, dapat diha gyud na siya ibutang sa intact nga table nga dili basta-basta matandog. Dili siya basta-basta mauyog because this can lead to inaccuracies later on sa atong mga timbang. Now, fingerprints, they can also affect the apparent mass of an object. So, tweezers or a tissue are recommended for placing objects on a balance. Now, inigtimbang na to pohon, no, naman gid tay laboratory activity intended for this. So, aside from wearing the surgical gloves, now dapat po mo gamit po tag tissue, no? Inibutang na to sa atong container or sa ato ang mga object no, nga pangtimbangon. It's because our fingerprints, mga good class, they can affect the mass of the object, considering that we have sweet glands in our palm. And so, if these sweet glands releases mga sweets, or sweet, sweat, and then kana siya nga sweat kay or naabay mga contaminants nga sa atong kamot, tapos mupilit siya sa atong gitimbang, then this can affect the mass of the object, no? The reliability and accuracy of the mass. Kay ang moisture man gud nga naa sa atong palm, pwede nga ma-transfer dito sa object, and this can add or this can increase the mass of the object that we are weighing. Now, these are the precautions in using an analytical balance. So first, we need to center the load on the pan as possible. So kung magtimbang ta, dapat i-make sure na to nga nabutang na to sa tunga, sa balance pan ang object. Second, we also need to protect the electronic or analytical balance from corrosion. And so the object that we should be weighing or we should be placing on the balance pan, it should not be reactive na mga metals no, or mga reactive na plastics. In other words, dapat mga non-reactive sila. Non-reactive metals, non-reactive plastics, vitreous or glass-like materials. Then third, we need to observe special precautions for the weighing of liquids and make sure nga walay mga usik, no? Walay mag-usik-usik, walay magbasa-basa, walay mga residues nga mahabilin sa sulod, walay lama-lama, no? Nga mahabilin sa balance pan. Then we also need to consult your instructor, or in a way, someone who is expert in calibrating the analytical balance if there is a need for adjustments. Fifth, we also need to keep the analytical balance and its case scrupulously clean. So, dapat limpyo gyud siya. And if ever na may mag-spill over na mga solids or mga chemicals, we can use this camel hairbrush or pwede na po paintbrush para mahinluan ang sulod, no? To remove those spilled material or dust. Sixth, we also need to always allow an object that has been heated to return to room temperature before weighing it. So, dapat pabugnawon sa nato before nato siya timbangon. Then, we also need to use tongs, finger pads, or glassine paper strip to handle mga dried objects to prevent transferring moisture to them. So, kung magtimbang ta, dili pwede nga kamot lang dito sa atong gamiton. Pwede ta magamit og tongs, pwede ta magamit og finger pads, and mga paper strip. Especially if mga dried object na sila, because lagi na possibility nga ma-transfer ang moisture nga naa sa ato ang kamot or sa atong palm dito sa object na ato ang timbang. Now, dili gina nato malikayan nga naagi mga mali nga mahitabo, no, in the process of weighing. Okay? Of course naman dyan ang mga error. There is always a room for error man yun in everything that we do. And so, in weighing, we have here two sources of error in which mali, like dili accurate ang makuha na itong timbang. So, we have here the buoyancy error and the effects of temperature. So, these are the two sources of error in weighing. Now, when we say buoyancy error, class, this is a type of error in weighing in which it affects the data, or it affects the masses. If the density of the object that is being weighed differs significantly from that of the standard mass. So, naikalahian sa density sa object na itong gitimbang and sa standard mass. And so, where does this error came from? Now, this error has its origin in the difference in the buoyant force exerted by the medium, which is the air, on the object and on the masses. In other words, because objects, they weigh less in air than in a vacuum due to the upward buoyant force from the displaced air. So, naay inconsistencies, no? So, kadtong mga objects na atong gitimbang, they weigh less in air than in the vacuum because of the upward force exerted by the air. And this can affect the overall na may upward nga buoyant force, no? So, this can affect the overall accuracy of the mass, no, that we get, no, from a particular object. The next, another source of error in weighing is the effects of temperature. And we have here two sources why temperature is a factor in weighing. First, we have the convection currents within the balance case exert a buoyant effect on the pan and the object. So, na convection current, di ba naaman siya sa different currents, katong convection, conduction, na siya. Movement sa air. Then second one, we have warm air that is trapped in a closed container, way less than the same volume at a lower temperature. Now, you already learned this in physics that hot objects, the molecules there are moving, no? They are constantly moving and exerting, or in a way, luhag sila. It's because of the heat, or reason niya. This can lead to a decrease or mas gamay ang ilang timbang as compared to that of an object na bugnaw siya. So the molecules are in place and they are not moving, they are tightly packed. So mas pulido or mas kuan ang yung timbang, mas accurate kapag bugnaw ang object. Which is why if ever naaman tayo mga pang-inito ng mga objects later on, dapat kanang mga gipang-init nato ng mga objects, before na sila nato timbangon, they must always be cooled. No, dapat pabugnawon sa siya up until room temperature before being weighed or before subjecting it to weighing. Okay, so that ends our discussion for the apparatus that are commonly used in determining the mass of a particular object. Now, in the next part, I'll be discussing the other equipments naman or apparatus used in different field, no, of different